Hi guys, I'm going to be doing number 2B for Webassign. So it says in a downhill ski race, surprisingly little advantage is gained by getting a running start. This is because the initial kinetic energy is small compared with the gain in gravitational potential energy even on small hills. To demonstrate this, find the final speed and the time taken for a skier who skis 75 meters, which is going to be your delta x, along a 35-degree slope, which is going to be your theta. Neglecting friction for the following two cases. And then I'm doing part B, which is starting with an initial speed of 2.5 meters per second. So first what you're going to do is I'm going to draw a triangle. And this angle right here is going to be your 35, and this length right here is going to be your 75. And what you want to do is you want to try to find your height, which is going to be that. So to solve for that height, what you're going to do is sine 30 equals opposite, which is the h, over hypotenuse, which is a 75. So then if you multiply that, it's going to be sine 30 times 75 equals h. So then your h is going to be 43 point, or for me at least, it's going to be 43.018. After that, you're going to set your potential energy equal, which your potential energy equals your mass times gravity times height. You're going to disregard mass right now. So potential energy equals your gravity, which is always 9.8, times height, which is 43.018. Solve for that. Potential energy is going to be 421.5764. Alright, so now since you have that 421.5764, you're going to set that equal because potential energy and kinetic energy are equal. Because energy is constant, so you're going to set that equal to half v squared. And to get rid of that half, you're going to multiply by 2 on both sides. Oops. And then that's going to get you 843.1528 equals v squared. And then after this, you're going to take the square root of both sides to get the final velocity, which will be 29.037. And this will be your answer for the first part of 2B. And it should be the same as the first part of your part A because the initial speed doesn't factor into finding the final speed. Alright. And so then we'll find the time. You're going to start off by using the equation v squared equals v naught squared, or v initial squared, plus 2a times delta x. And you know all of these variables already, so v squared, which is your final, which is what you just found, is going to be 29.037 squared equals your v initial, which is going to be the one that they gave you, 2.50 squared for me, plus 2, and then we're going to try to solve for acceleration, or that's what we're trying to solve for, times delta x, which they also give you, and minus 75. Once you simplify that, mine is going to come out to 843.1528 equals 6.25 plus 150a. After you get that, you're going to subtract the 625 from both sides, so that's going to be 836.9028 equals 150a, and then divide by 150 on both sides to isolate a, so then your a is going to equal 5.579. But you're not done. You're going to use the equation v equals v initial plus a times t in order to solve for time. And so v final, again, you know that's what we solved for in the first one. 29.037 equals v initial, which is that 2.50, plus 5.579, your acceleration, times t. And if you simplify for this, subtract the 250 from both sides and divide the 5.579t, so then t equals 4.756, and that will be your answer for the second one. Hope that helps.